Hello, good evening, friends. Myself, Malesham Devasane. Welcome to Unacademy, which is the largest online education platform for GATE, Computer Science, and IT. Here today, we are going to see the compiler design, the second topic, which is lexical analysis. But you know that in the introduction, we have left with few topics like phases of a compiler, and also we require to look at what is symbol table, and then we are going to begin the first phase, that is lexical analysis. So let's begin today's session with introduction to myself. That is, I have studied MTech from IIT Bombay. Then I have started taking the classes for GATE. Nearly 12 years of teaching experience is there in GATE subjects, where I'm going to take TOC compiler programming on this channel. If you are going to take the subscription on Unacademy, use the code DEVALIVE to get the 10% discount. Also, you will have the guidance to prepare for GATE exam from me. And these are the subjects that I handle, apart from my friends, colleagues who are also going to take other subjects. And I'm here going to deal C, TOC, compiler design, and also algorithms. And what are the advantages you have coming to the plus subscription? You know, Unacademy provides two kinds of classes. One is special, where you can freely attend the sessions on Unacademy, and also the paid courses, which we call as plus and also iconic. So the advantages are every subject will have a practice course, and every subject you will have a regular course, which can be you can call as complete course, and every subject has a revision course, and every subject will have a GATE solving course separately, and you will have the mixed subject course sometimes and doubt clearing course separately. So these are the advantages if you are taking the subscription on Unacademy. And for plus, you have like live classes. बहुत अच्छा benefit है ये live classes की फंडा, and this is just like a physical class, and more than physical class. The reason is you are always going to interact with the faculty. That doesn't happen in physical classes, but on live classes you can interact whenever you have the doubt immediately. So, and also you will have crash courses, weekly tests, doubt solving sessions separately. You can use English and Hindi to speak with educator. You'll have rank improvement batches, and iconic plan is another subscription, and which is going to have all the benefits of plus subscription, where iconic also gets an advantage of one-to-one guidance. You will be assigned with one expert, and you are welcome to contact to improve yourself, and you'll be getting guidance. You will have study planner, you will have a separate booster sessions, analysis on each test that you attempt, and you will have a personalized and super study material. And if you are looking at a plus subscription, the popular plans are 1, 2 years and 1.5 year. And if you are looking at 1 year plan, 27,225 after applying DEVALIVE code. And 1.5 year, it is 34,650, and 2 years 39,600. And guys, those people who are studying BTech, who are in second year, third year, and you might be paying for 2 years, but you will learn. You can learn every subject which is there in your BTech from Unacademy. So that's one more advantage you will get through this subscription. And most of the subjects that we teach in various exams, like GATE exam, the most of them in every semester will have 2 to 3 subjects. That's going to help you a lot. And you will be ready when you are in third year or final year. You'll be ready for the GATE exam too. If you are coming for iconic subscription, which you will have 45,225 for 1 year, 66,600 for 2 years. Yeah. And also join this GATE aspirants Facebook group to get regular updates from us. And this is a very good channel from us, Telegram channel. You can subscribe to this to get notifications and materials. All of them freely you can get from this channel, Unacademy GATE CS. Yeah. Hello KD, Vaishnav, how are you? Chakraborty, good afternoon. Hiran, good evening. Alright. And if you are watching this video, guys, please like this session. I'm waiting for your likes. Please do that. Yeah. Thank you. Thank you. Please do like this session. If you are following this channel regularly and you are enjoying with our sessions. And also, guys, you may or may not know that we have so many YouTube channels from Unacademy. All these channels for you people, and you share with your friends. They can also learn the content freely from us, and that is Creatics Gate channel, Unacademy Gate ME, Unacademy Gate CE, Unacademy Gate Telugu, and Unacademy Computer Science. And so many channels are available, which are all taken from Unacademy educators. So these are very interesting for those people who want to learn. And also we have this channel dedicated for those guys who are preparing for GATE computer science mainly, and all subjects that we are going to take before the exam. So please keep attending the classes without discontinuing, and be regular to learn everything that you require for exam. Yeah, it's the time to like and subscribe if you are not done, and share with your friends. Let's begin today's class, guys. Compiler design. In the first session, we have seen translators, and we have seen what is the preprocessor. We have also seen linker, loader functionalities, right? And loader, we have seen limited functionalities because we are looking inside the program what is happening, but outside the program, loading the program, that's also done by the loader, and it is a part of the operating system, you can say. But this kind of loading you can also implement separately. Yeah, today's agenda is to learn about phases of compiler. Then we will look at errors in C programming, and we will introduce little bit a lexical analysis. Then we'll also look at what is symbol table during the phases of compiler. Okay, and any topic which will not be covered in this session will be continued in the next session too. So let's begin today's session with phases of a compiler. And how many phases are there in a compiler, guys? Please keep replying. Please keep replying. How many phases are there in compiler? Is it 5 or 6 or 7? What is exactly? Guys, what is exactly? Let's see who will answer that. Let's see who will answer that. How many phases are there in compiler? Look at that. You only are answering 6, 7, and all answers are right. Even still you can answer 5, 6, 7, but it depends on your view. Why do you say 5? All are right. If anybody answering 5 phases, that's also right. 6, but this kind of question is useless in the exam oriented, because this is not going to be asked in the exams. If any exam is asking how many phases in compiler, means they do not know how to make the questions in the exam. So let's look at why we have many answers for this question. Let's look at the 5 phases. Okay, let me write just names rather than showing right now everything. How the 5 phases looks like. How 6 phases looks like. how 7 phases looks like. Maybe you are studying first time regarding this. Okay, the number of phases in a compiler can be answered many ways, but you should know why we answer this way. And you can answer that lexical analysis, lexical phase, syntax phase, semantic phase, intermediate code generation, and another one, code generation. When somebody is saying the 5 phases, it means there is a code optimization. That word is there, that was the part of the last 2 phases. In the last 2 phases, code optimization is also built inside, and that are mainly the compiler built based on 5 phases. That other phase is optimization, that is the part of 2 things. The code optimization is a concept where it tries to optimize the code which can improve the actual code. So let's look at another one. When somebody is saying 6 phases, it is not actually 6, it is 7 only. But you can't show like this. Rather, I can tell that I have 1 lexical analysis, 2 syntax analysis, 3 semantic, but I can't tell you which order here. I can tell you intermediate code generation, 5th code generation, 6th code optimization. The code optimization is just a word, but actually it is used in 2 places. It is used in 2 places. If I want to show 7, this is exactly right answer. 7 is also fine. Lexical analysis, then syntax analysis, then semantic, intermediate code generation, then code optimization, then code generation, again code optimization. When somebody is saying 6 phases, they are actually using code optimization once, but that actually comes practically 2 places. Yeah, 7 is exactly the number of phases that are present, but out that 7, when we are speaking in theoretically, there are only 6 names. The code optimization is used twice. So 6 phases who are saying it, they are saying code optimization only once. But when it looks theoretically, the code optimization can be part of the intermediate code generation and code generation. So somebody can come up with a solution, the code optimization that can be part of ICG, this code optimization can be part of code generation. Then it looks like 5 phases rather than 7 phases. So best answer is the 5 phases. When you are assuming code optimization is a part of the 2 phases, 7 phases is exactly the compiler contains. Yeah, so most of the time the 7 is appropriate. Right, somebody says 5, in that sense that code optimization was a part of the last 2 phases. Somebody saying 6, okay, that is meaningless, but where they are assuming the code optimization is theoretically they are speaking 1, but actually practically it comes twice. Yeah, everybody, so this is the one you need to understand, 5 or 6 or 7, that surely 7 phases are there where the code optimization is going to come twice, but both times code optimization word only same, but algorithms are different. Everybody, implementation is different. One is the code optimization on intermediate code, another one code optimization on code generation. Everyone, so this is what we know about the phases. Now let's look at how to understand these phases. How many is we said? Don't worry what I'm drawing it. This looks something different. Okay. This is a lexical analysis. The output of lexical analysis is an input to syntax analysis, and output of syntax analysis is an input to semantic analysis. All these words are theoretical. Practically, you can build all the three phases as one module. So, practically, you may not see this many phases are there, but the meaning is there inside the program. These three things are going to be done using single module. This is intermediate code generation, and another one code optimization, but this is done on the intermediate code. Another one code generation or code generator. Total we have 7 phases. 7 phases. Yeah. Now these 7 phases are built either as pass 1, means in a single pass the complete output comes. That input is a C code after pre-processing, and output is assembly code. This entire 7 phases you can implement in a single pass, or you can implement in 2 passes. So what do you mean by pass? You can assume this compiler is divided into one module, means it's a one pass compiler, means all the 7 phases are built as a one module. And if I say 2 passes, then you can assume that the compiler built in 2 modules. So that what is the advantage of implementing using many phases or using many passes, we are going to learn today. Yeah. So let me talk about right now. Do not worry much about the each phase, because that is going to be our syllabus. If you try to understand what is lexical analysis, you may not right now, because just introduction to compiler. So what you can understand now, what is input and what is output of the each phase. I can just tell in C code it is going to be considered as the characters only. That is character stream. The whole C code is assumed as just a sequence of characters. Then what lexical analysis does, it produces token stream. It will convert into tokens. The characters will be converted into tokens. That is lexical analysis job. And syntax analysis is going to produce the parse tree. And syntax analysis takes a token sequence and produces a parse tree. And semantic analysis is going to understand that parse tree by assigning the translations to it. That will be annotated parse tree. And so far what is happening, we have C code only. We are not converting C code into any code. We are trying to analyzing the code to understand what is there in the code. Now first time the intermediate code generation is going to take the C code as an input and produces the intermediate code as an output. That intermediate code has so many representations. We will study in intermediate code generation in that chapter. We will study in intermediate code generation chapter. Right now, just assume intermediate code generator is going to take input as a C code, that is annotated parse tree, and produces intermediate code. And code optimization is try to do some optimizations on the intermediate code, then it will again convert to intermediate code. So code optimization is going to happen on intermediate code, IC, as in that IC means intermediate code. And code generation is going to take input as intermediate code is going to produce the assembly code. But this code optimization is going to be on assembly code. AC means assembly code. And two code optimizations are actually taking input different and output is also different. In the first code optimization takes intermediate code as an input and produces intermediate code as an output. And the second code optimization takes input is assembly code, output is assembly code. Theoretically, you may use algorithm similar, but practically they cannot implement it in the same way. Their input and outputs are different. Is that clear? So we have this many phases in compiler. When it comes to these phases, now let's look at these phases in another way. Okay, now lexical, syntax, and then semantic, and then we have intermediate code generation, and then we have code optimization, and then code generation. And why I am doing again, you will understand what I am going to do now. So we have this many phases now. I have drawn in different levels, but that actually you can assume as okay. So this is a lexical analysis and syntax analysis and semantic analysis, intermediate code generation and code optimization, code generation and code optimization. Now what I am going to do here, look at this here. When you give C code here, and first time that intermediate code generated here, and optimization version is there, and finally assembly code generated here. Of course, 2 times assembly code, here 2 times I code, intermediate code. Everyone, so if you are using C compiler, here we are going to deal with 3 kinds of codes. One is a C code, other one is I code, intermediate code, and other one is A code, assembly code, and other one is machine code, but that is not now, that is later on. Okay, that is after assembler. Here assembler is not there. In these 7 phases, assembler is not there. So later on assembler comes, it produces M code, machine code. Yeah. Now when you look at these 3 types of codes, when you are looking at these 3 types of codes, what is going to be the relation between them? And up to here, the output, up to here, that is machine independent outputs. All these phases are not going to depend on the machine, what they are going to produce, what they are going to take. They both are the machine independent. But code generation takes machine independent code but produces the machine dependent code. So these are machine dependent optimization, machine dependent phases, you can say that, right? Because their outputs are machine dependent. So why we say compiler, when you are going to look at whole compiler, we are going to say machine dependent. Why? Because output is assembly code. The compiler is, even though all the phases are not depends on machine, but output of the compiler depends on the machine, because assembly code can be produced only when you know about the machine. Only when you know about the machine. But that means compiler knows about a machine, That is how the compiler knows how to produce the assembly code. And what is best is it better to implement in pass 1 or pass 2? That is the reason these compilers are built based on 2 pass compilers. If you have 2 pass, in the first pass which are independent of the machine, you can take as one module, which are depends on the machine, you can take a second module, and you can integrate them when you install the compiler on your machine. So it's better to implement as a pass 2 compiler. So compilers are many types. Pass 1 compilers means all the phases are built as a single module, and pass 2 compilers, 2 pass compilers, 1 pass compiler and 2 pass compilers. In 1 pass compiler, all phases built in one module, all phases are combined. Here all phases are divided into 2 modules. If you are needed 3 pass compiler, you can do that. If you have any advantage with that kind of modularity, all phases are divided into 2 modules. In module 1, you can implement this one, and module 2, you can implement last 2 phases, code generation and code optimization. Everybody, so this is called as pass 2 compiler if you are dividing into 2 modules. And if you really want 7 modules, and that's going to be too costly because you need to separate all of them, so that each phase might require extra knowledge. So it's better not to implement 7 phases separately. So better to implement either 2 or 3. Today 2 pass compilers are very popular. Yeah, everybody. So this is what the compiler, 1 pass compiler and 2 pass compiler. 1 pass compilers, all phases just looks like one program, and 2 pass compilers, that all phases are divided into 2. And if you look at here, lexical, syntax, semantic, they are actually not different programs. They are actually one program we are understanding in 3 different meanings, with 3 different meanings. Everyone, yeah. In this compiler design, we are going to learn topic by topic. First chapter, after introduction, the first phase we will learn, and second chapter, second phase, and third chapter we are going to learn slowly further. Is it clear? So first 2 chapters are going to be lexical analysis and syntax analysis. Okay, now let's look at again still I have a question mark. Why do you need many phases? What is the advantage of having this many phases? And you must question what is the advantage of learning all these phases separately. Do you have any use with this many phases to understand theoretically? Practically somebody implemented, but why really we study these phases separately? Think about, guys, think about. What is the use of learning these 7 phases separately? Okay, I'm just writing now. You understood 7 phases. So I'm going to put a name P1, phase 1, phase 2, phase 3, and 4th one, 5th one, 6th, 7th. So I'm naming it, guys. Instead of writing every time these things, just I'm writing 7 phases. And there is one thing, a data structure that we are going to maintain and handler to report your errors. So there are 2 things that every phase is going to communicate. It's going to be created by compiler. and what is this is called as symbol table. Like you have a literal table, but symbol table is more important. Every phase is going to interact with this symbol table. And another one is error handler. Any error comes from any phase, then you will report to the error handler. You will report to error handler. So error handler, either it can correct it or it will report to the programmer, and 99% it will report to the programmer. Error handler will report errors. Look at input is a C code and output is assembly code. And here the symbol table is a data structure. You can implement using any data structure that is suitable to implement a symbol table. Maybe like array or hash table or combined hybrid model. And we will see what is a symbol table. And error handler, it's just a program. Either it can handle an error or it can report an error to the user. And each phase can produce error. The first phase can produce like lexical errors, will be reported to the error handler. Second phase is the syntax errors. Third phase, the semantic errors. And other phases, the errors are not easy to understand. They are called as unavoidable errors, fatal errors. These fatal errors may be because of insufficient space in the system. Actually, we want to convert into intermediate code, but intermediate code may require a lot of space than your actual program. Then it may generate fatal errors if you don't have sufficient space, right? And the code generator may be asking require more addresses or more registers, but that are not available during conversion to the assembly code. So it's going to produce fatal errors. So fatal errors are something which is internally. It's not because of your program, it is because of the system insufficient resources. The fatal errors may happen that if we change the system, then these fatal errors can be avoided. But our programming language depends on first three. The first three errors are called as compiler errors. The compiler errors are three types: lexical, syntax, semantic. Yeah. Use of symbol table. Right now, the use of symbol table you cannot understand because you need to learn each phase of the compiler. So I will be talking about slowly. One small program, because as you are asking the question, so it's I'm going to talk about symbol table just after these errors. So just wait for 2 minutes or 3 minutes to understand what is the symbol table. So let me start with errors first, and we have two things here. We have two things: errors and we have symbol table. All the phases are going to use the symbol table. Remember that all phases are going to use the symbol table, and all phases can report an error to error handler. Everybody, each phase not only the job to produce some output, it also reports an error if there is any. Okay, what is error? In C programming, guys, in C programming, I'm talking about errors. Errors are two types. Then I can say compiler error or let me tell you many errors. Instead of saying compiler, during compilation, and runtime errors. During compile time, remember, compile time. During compilation, the error may happen because of preprocessor error or maybe compiler error. All comes under during compilation only. and even the linker errors can happen during compilation. During linking time, that is just after compile time. If you are talking about specifically what is the compile time, that during compilation by compiler, but that during before runtime, everything we call in general compilation process. So be careful. Compile time, if anybody is operating from linking time, then you must understand compile time, linking time, both are different. But usually this happens before runtime. People calls as compilation errors. Okay, so preprocessor time, if you assume, compile time, linking time, loading time, runtime, this many times you can assume in general. Okay, preprocessor errors may happen because of you are writing hash include instead of spelling mistakes like LUDE. Then this is not the preprocessor command, so this will generate preprocessor errors. And compiler errors, three types: lexical, syntax, and semantic. And do not worry what they are. We are going to see in this subject, and in this subject we are going to learn. Don't worry what is lexical, what is syntax, what is semantic. Basically for the programmer, compiler errors are only well known, familiar. And if you are going to design a compiler, then you must be familiar with lexical, syntax, semantic. Everybody? So, and linker error, you are not able to resolving some external references. Like you have called extern int x, but x is not there in any file. So resolving during the external references. Suppose you are writing hash include p1.c, but that is not available. Are you clear? So during linking, if any of the file not available, if any external file not available, not exist, sometimes the variables, external variable is not defined in any program, but you said extern int x, that is only declaration. It is going to look at where is that x. If x is not available in any file, it is going to generate linker error. And runtime errors, so many, like you have divide by zero error, and you may have infinite loop, that's a logical error, and you have infinite recursion, but infinite recursion will not happen. You may call it as infinite recursion, but this will be actually converted to stack overflow. An infinite loop is supported by the operating system, no problem. Most of the time supported, but sometimes if you ask more necessary, it will not support. Okay, divide by zero, infinite loop, infinite recursion. What else you have? Accessing, like there are so many pointer problems. If you are adding wild pointers can create runtime errors, and null pointers can create runtime problems. Null pointer dereference, and dangling pointer accessing, trying to access the address which is not exist in user space. Dangling pointer can create problem, etc. Pointers can create runtime problems, and you are accessing out of array bound, accessing out of array bound. Array always has a lower bound, upper bound. You can't access outside. And you also have segmentation fault that can happen with the pointers or with any address that you are dealing invalid. Segmentation faults like using scanf address of x, but actually address of x should be used with the scanf if x is an integer, but ampersand you have missed it, then it's just like a wild pointer. It looks like, yeah, segmentation fault, and so many runtime errors are there. Yeah. Now these things we will learn slowly. Lexical, syntax, semantic. Our target is to learn these three guys because compiler we are learning. compiler we are learning. Our target is to learn what are the compilation phases and what kind of functionalities are there for each phase, and we are going to learn all this. Everyone? Yeah. Now, what is a symbol table? As you know, I have so many questions. Today I will ask you two questions. Try to answer it later on. Okay, what is symbol table? Basically, we write a program. And do you assume only one symbol table is there? It is the system compiler dependent. You can have more than one symbol table. For global variables, symbol tables can be many. One or more symbol tables can be maintained by the compiler. I just said symbol table, but actually one or more symbol tables can exist. They can be linked. Symbol tables can exist in a compiler during compilation. And this program, and you do not know, each depends on that number of symbol tables depends on the scope. If you have a different scopes, you can implement different table. Depends on scope. Here I have one scope here. Here there is another scope. It is my choice. I can implement two different tables and then I can link, or I can have the same symbol table. So what is basically symbol table? Like you have a main. And main basically it's a function name, but it is also an address. And X is also variable name, but it is address. Y is a variable name, but it is address. And A, but all are not in the same scope. So don't assume that you will have a same symbol table for all the identifiers. And you know, this is first chapter we are going to learn. First chapter we are going to learn how symbol table is going to be created. But anyhow, this main X, Y, A called as lexemes, because that you have written is lexemes. Your program is lexemes. Your program is set of lexemes because lexically valid. If it is lexically valid, we can call everything as a lexeme. And what do you have for this? You have internally, you may have token name for this. You may have so many things. Right now I can't tell all of them, but assume so many are there. You may have so many fields for this. And why compiler required to maintain all of them? And for function names, it can implement separate table also. Don't assume it will implement in the same table. Just I am trying to tell you what do you have. And tell me guys, what a function name? This main is a function name. And function name, what attributes are required? You know, it can be line number, and it can have number of arguments, and type of each argument can be maintained separately. Type of each argument and return type. And for the function that is. And if I want to maintain separately for these other variables guys, so let me write X separately then. Just I want to keep separate names for this. It's better to have that way. Okay, you may have something else. And what else these variables can have? Variables, let's say these are lexemes, and they also have a token name, line number, and these variables will have type. It will not have number of arguments. Variable as a type when you declare it. And what else have? Offset. Offset, because how much distance is there from main, so that this offset is very easy to calculate rather than address. But main can have an address that is going to be assigned, and if you have anything else that is required internal to the compiler, it will be maintained. It will be maintained. It will be maintained. And guys, this is how the symbol table information is going to be maintained. Yeah, everyone, yeah, please maintain running notes. It's not about the notes. If you are watching the videos, it's always good to make in running notes, and running notes may or may not available, but it is always recommended to maintain running notes. This video is available, and please write these notes on your own so that you will enjoy when you read again this compiler. Everyone, yeah. And symbol table, are you worried about the symbol table now? Because you don't know already each phase of the compiler. How do you know that is what do you mean by token? What do you mean by line number? What do you mean by offset? And that is what I am talking about. Symbol table is symbol table. Let me help you. Symbol table is a data structure. We only know about definition now, but this use you will be knowing in phases. It is a data structure. You can say table, or you can say array. It maintains attribute, that each column is attribute. There are so many properties are there. Attribute information of each identifier. Who is identifier? Identifier can be function name or variable name. And function names will have different properties, and variable name will have different properties. Some of the properties may be common to common to both. Everyone, so symbol table is a data structure. It's going to maintain the attribute information, that's the properties of each identifier. That what are the attributes? You can see that lexeme, token, line number, and number of arguments for this function name. But when it comes to variable name, they will have a line, type, offset, and so on. Yeah, this is the overview of the symbol table. And I'm saying again, don't assume a program as a single symbol table. Program can maintain many symbol tables, like global symbol table to maintain global variables, attribute information. Everybody, so the symbol tables can be many, right? Each scope can maintain different symbol table, and they can be linked one with other. Yeah, fine. And this is how what I'm talking about. We have errors, we have symbol table. Now how do you know which error is what type of error, or which error produced in which program? And that you will understand depends on your phase. Lexical errors are different from syntax errors different from semantic errors different from runtime errors. So here mainly you require to understand this compiler errors. Okay, right now I'm just going to say the first phase of the compiler, the lexical analysis, and I'll give an introduction a little bit. Tomorrow we are going to start the first topic, and before that I have a question for you. As I said, you can think about it. Why do we need many phases in compiler? Why don't you implement one phase for all of them to combine, right? Why we need many phases in a compiler? Okay, some of them, like modularity. If you have modularity, you can reuse them. Then if you want to reuse, who will reuse them, right? That is what the question mark. Why we need many phases in a compiler? This is homework for you, and definitely this answer you can find out in the coming sessions, but this is homework to think about why the 7 phases are required to learn. Why not one phase? Why we have implemented 7 phases in a compiler? What kind of benefits you will have if you have many phases? Okay, we will see in coming sessions about this. Okay, lexical analysis. and you can also call it as a scanner. You can also call it as a token recognizer, or you can call it as token producer because it's going to produce token. And you can also call as a linear phase, and so many names like lexical analyzer, lexical phase. Okay, analysis phase, both are same here. Yeah, and many names for the same phase. What is the job of lexical analysis, right? And what kind of errors it produces? Lexical errors, we know, but how do they look like? That we will see in detail soon. This is your lexical analysis. You have program here. We assume only characters are there, character sequence, that's all. We call it as a character stream. Whole program treated as just characters. It doesn't know keywords are there right now, but it will identify. This lexical analysis yeah, good Satyajit. Good evening, Bharat. Yeah, guys, keep liking the sessions, guys. Token sequence, it's going to produce the token stream. You can say that token stream of tokens, and it's going to find out if any errors are there. Lexical errors will be reported to the error handler. If any will be reported, and it is going to use symbol table. So this is what the next coming topic for us. What is lexical analysis and what are the functionalities of lexical analyzer, how it identifies the token, and we are going to answer every question in detail tomorrow in the coming session. And today we have only learned few things, phases of a compiler, and still we are having one question mark. Why do we have many phases in a compiler? And what errors are there, like runtime errors, compile time errors, and what is symbol table? That's all we have seen. But how exactly the symbol table is going to be implemented, that you will know only when you learn one by one phase in a compiler, right? Why? When will be the token entry will happen, and when will be the line number, when will be the type entry. So these entries will happen inside the compiler. Okay, so compiler is going to create the symbol table, and it is going to be updated in the compiler, and so that the phases can see some information related to the identifiers. Okay, in coming session we are going to start the lexical analysis from the beginning again. Okay, so just think about what is this lexical analysis, what is going to happening for our program, right? Yes, correct. Yeah, thank you so much for attending today's session, guys. Keep attending these classes and like the session before leaving, and follow my profile and follow my classes if you are enjoying. And tomorrow's schedule is available on Unacademy or in group channels. I will post the links tomorrow because not yet decided. And please follow all classes which are running on this channel, and please use DEVALIVE code if anybody want to take this subscription. It is always good to know why do you require to come to the Unacademy, because of the best educators are available on Unacademy, and we left institutes and we were working in coaching institutes earlier, and now we left the institutes because of the COVID, and we wanted to give, even we are not aware of Unacademy before joining here. Now everybody knows what is Unacademy. Now everybody is jealous about Unacademy, because the most of the content we are teaching freely. Somebody is teaching by taking the price for the each subject, but we are not charging anything. But we are also charging when you want to learn everything from us, then definitely you require to pay. And even we are teaching everything on channel, but still we have more to teach and we have more to guide. That is what the plus subscription. You will have doubt sessions, you will have practice questions, you will have apart from doubt clearing session, you will have separate study material, you will have live interaction, and these things we are going to miss on this channel. But still the best channel for computer science, Unacademy Computer Science Channel. So please keep visiting this channel and learn from us. We are here for you, and definitely we will rock in this coming GATE exam and other exams too. And believe that we are here for you. And please like this session, whoever following us, and please also share with your friends who wanted to learn, and please subscribe to this channel. Let us reach many students whoever want to learn from us.